Hi, smart learners. Welcome to today's episode and a continuation of our class on logarithm. Today, we'll be looking at examples on logarithm questions. So, if you are yet to watch the video on logarithm, which is the video I made on the laws of logarithm, so it's very, very important that you revisit those laws and you know how those laws operate. It's very, very important as we'll be using those laws in solving logarithm questions. So the first question we'll be solving today, example 1, is a NECO question. So we're asked to simplify log 16 base 2 minus log 4 base 2 plus 2 log 4 base 2. So solution. So you agree with me that they are all in the same basis, base 2, base 2, base 2, log 16 base 2, log 4 base 2, log 2 base 2, log 4, 2 log 2 base 2. So the first thing I want to do is I want to return these two back to this number. You remember from our laws of logarithm that when we have the log of 4 to base 2, I can simply say that I have the log of 2 raised to power 2 base 2. So I can express this 4 as an index, which is 2 to the power of 2. So I can bring this 2 to this side, just like we have here. So I'm going to be having 2 log 2 base 2. So just like these two can come here, these two can also travel back. It can also travel back. So it's just the reverse of that particular law we learned in our laws of logarithm. So if that is properly understood, I think we can proceed into solving. So I have log 16 base 2 minus log 4 base 2 plus log 4 to the power of 2 base 2. Mind you, it's going to come now as the power. So now I can apply my law, the basic law, which is when we have the subtraction, we divide, and when we have the multiplication, we multiply. So since they have this, when we have the addition, we multiply rather. Since they have the same basis, log 2, log 2, log 2, we can just pick the log of a common base and do 16 divided by 4 times 4 to the power of 2 is 16. It's very, very important. This minus sign is in front of this log 4. So it's going to take the division sign, and this plus is going to be multiplication for this. So I'm going to be having log to the base 2 of 16 times 1 over 4 times 16. It's important that I change this division sign to multiplication. To do that, I just have to reciprocate the right-hand side, so which is 4. So 4 here 1, 4 and 16 is 4. So I have log 4 times 16 is 64 to the power of, 4 times 16 is 256, not 64, 256 to the power of 2. So I can simply see I have 256 divided by 64. Yeah, it's the same thing. So 4 times 16 is 64. Yeah, it's 64. So it could have been 16 times 16, which is 256 over 4. Then 4 here, 1, 4 into 256, that's 64. So I have log 64 base 2. So I can express 64 to its index form. So I can have log 2 to the power of 6 base 2. So 2 to the power of 6 is index form of 64. So I'm going to bring this power to this side. So I can have 6 log 2 base 2. And you know the log of a number to its base is 1. So log 2 base 2 is 1. So I have 6 times 1, which is what? 6. Because we know that the log of a base, the number of a number to its base is what? Is equals to 1. So that solves the problem of this particular question. So let's check out the next question and see if we can dirty our hands with that. So I have, it's also a NECO question, example 2. So I have simplify log 8 base x minus log 2 base x plus log 4 base x. So in this case now, I just have to pick the log solution. I just have to pick the common log to the base. They're all in base x, base x, base x. Now I have to perform the operation 8 divided by 2 times 4. So I'm going to have log to base x of 8 times 1 over 2 times 4. I'm going to change the division sign to multiplication. I'm going to reciprocate this 2. So 2 here 1, 2 here 4. So I have log 4 times 4 is 16 to base x. I can leave my answer like this, or I can say I have log 2 to the power of 4 base x. I can bring 4 to this side, so I can have 4 log 2 base x. That's my final answer. Let's take another question. Example 3. So here I'm asked to evaluate log 10 base 5 plus 3 log, sorry, not 3, plus log 10 base 20. So this is a why question. So here I'm just going to pick the common law because they have common base. So I'm going to use the addition law here. So log to the common base of 5 times 20. So whenever we had the addition sign and they are to the same base, we just pick one of the bases to the common, one of the log to the common base, and we multiply the numbers 5 times 20. So I have log 100 base 10. So we can express 100 to its index from that log 10 to the power of 2 base 10. So I can move 2 to this side. So I have 2 log 10 base 10. So I have 2 times the log of a number to the base is 1. So my final answer is 2. All right, so let's check with example number 4 and see how we are doing. I have 1 over 3 log 125 base 10 minus 3 log 3 base 10 plus log 54 base 10. So the first thing is, if I have a number to the in front of the log, I have to return it back as power. So I'm going to have log 125 raised to the power of 1 over 3 base 10 minus log 3 to the power of 3 base 10 plus log 20 plus log 54 base 10, which is the same thing as 125 raised to the power 1 over 3 is the same thing as 5 raised to the power 3. So I can have log, the index of 25 is 5 to the power of 3 times 1 over 3 base 10 minus log 3 to the power of 3 is 27 base 10 plus log 54 base 10. So 3 can cancel out this 3, so I can have log 5 base 10 minus log 27 base 10 plus log 54 base 10. So I can perform my operation here. So I have to pick a log to the common base because they have the same base, base 10, base 10, base 10. I can say addition and subtraction here. So I'm going to pick 5 divided by, because I have a subtraction sign there, 27 times, because I have an addition sign, 54. So I have log to base 10 of 5 times 1 over 27 times 54. So I have 5 times 54 is log to base 10 of 27 here. So 5 times 54 is 270. Can use your calculator to do that. So 27 here, 127 into 270, that's 10. So I have log 10 base 10, which is the same thing as 1. So the answer to the question is 1. So this is also a NECO question. So let's check with question 5 and see how we are doing with our practice. I'm asked to simplify 1 over 2 log 10, log 25 base 10 minus 2 log 3 base 10 plus log 18 base 10. So I have log of 5 to the power of 2, that's 25, times 1 over 2. That's why you move this 1 over 2 to this side. Then to base 10 minus log 3 to the power of 2. That's why you move 2 to this side. To base 10 plus log 18 base 10. So 2 can cancel out 2. So I have log 5 base 10 minus log 9 base 10 plus log 18 base 10. All right, in this case now I can pick the common log to the common base. So I have 5 divided by 9 times 18. So I have log to base 10, 5 times 1 over 9 times 18. 9 here 1, 9 here 2. So I have log 5 times 2 is 10 to base 10, and log 10 to base 10 is 1 also. So this fifth question is also 10. All right, let's check with the sixth question and see. So I'm also asked to evaluate without using log tables. I have 2 log 6 plus 1 over 2 log 625 minus 1 over 2 log 81. So here we do not have any base. So the base is just in base 10, or you can decide to pick any base that you like, but the base is base 10. All right, so here we just have to do is just let's return this to the side, return this to the side, return this to the side. So I can have log 6 to the power of 2 plus log 625 is 25 to the power of 2 times 1 over 2 minus log 9 to the power of 2 times 1 over 2. So 2 cancels out 2, 2 cancels out 2. So I have log of 36 plus log of 25 minus log 9. So I can have log, because they have common base, 36 times 25 divided by 9, which is the same thing as log of 36 times 25 times 1 over 9. So 9 here 1, 9 and 36 is 4. So I have log 4 times 25 is 100 base 10. So I can say I have log 10 to the power of 2 base 10. As I bring 2 to this side, so I have 2 times log 10 base 10 is 1. So my answer is 2. Okay. So I have another question here. I have question 7. Question number 7. So I am asked to simplify log root 65 to base 10 plus log root 2 to base 10 minus log root 13 to base 10. So this is also simple. I just have to pick the log to the common base and perform the operation. 65 times 2 divided by 13. So these numbers are called surds. They are irrational numbers, and there are ways we manipulate and play around them. So in a subsequent video, I'm going to be talking about surd as well. But for now, let's just take the basic rule of surd, which is that whenever we have something like this, we can actually bring the common root and multiply the numbers together. We can do that for addition, for multiplication as well as for division, but we can't do that for addition and subtraction. All right, so what we have here is the log of root 65 times 2 times 1 over 13. That is by making this 1 over, because I have this division here. So 2 base 10. So 13 can go in 65, that is 5 times. So 13 here 1, 13 and 65 is 5. So I have log 2 base 10 of the root of 5 times 2. That root is just too long. So I have the log of root 10 to base 10. So I have log of 10 1 over 2 then base 10 because root 10 is same thing as 10 raised to power 1 over 2. So I can bring 1 over 2 to this side. So I have 1 over 2 log 10 base 10, which is the same thing as 1 over 2 times 1, which is the same thing as 1 over 2. Okay, let's check with question number 8. Question number 8, I have 2 plus log 20 base 10 minus log 2 base 10. So to solve questions like this, it's quite very simple. What we need to do is just that we take an assumption that 2 is multiplied by 1. So we can have 2 times 1 plus log 20 base 10 minus log 2 base 10. So I can have 1 is the same thing as log 10 base 10 because of this common log. So I can have 2 times log 10 base 10 plus log 20 base 10 minus log 2 base 10. So the assumption here is that we are taking here is that the log of base 10 to base the log of 10 to base 10 is 1. So instead of writing 1 here, we just change it to log 10 base 10. So we have not done anything here. We've not increased our equation, or sorry, our expression. We've not increased our expression by anything. So we are just multiplying this side by 1. And we know that whenever we multiply a number by 1, we have that number. So it's still not an increment to any part of the solution. It's just that we want this question to be solvable. So I can move to this side, so I can have log to base 10 of 10 to the power of 2 plus, sorry, times now, times 20 divided by 2. So I can have log to the power of 10 of 100 times 20 over 2. So 2 here, 1, 20, 20 is 10. So I have log 1000 to base 10. So I can express 1000 to its index under 10 raised to the power 3 to base 10. So I can move 3 to this side. So I have 3 log 10 base 10. And log 10 base 10 is 1 from here. So we can just do 3 times 1, which is what? So that's about that. Let's look at question number 9 and see what we can do with that. So I have log 45 to base 10 plus log 9 raised to the power minus 1 to base 10 is 9 minus log 2 raised to the power minus 1 to base 10. Alright, so what I need to do here is very simple. I have to pick the log to the common base and do 45 times 9 raised to the power 1 divided by 2 raised to the power minus 1. So I can have log to base 10 of 45 times 1 over 9. So since we have a division sign here and we have a negative sign here, so this division is going to make this 1 over 2 raised to the power minus 1. And in short, we have, so let's just do that. We have divided by 1 over 2. And we have log 45 times 1 over 9 times, so we change this to sign and we reciprocate again, times 2. So 9 here 1, I have a base 10 here, 9 in 45 is 5. So I have log 5 times 2 to base 10. So I have log 10 base 10, which is more. So this is how we manipulate and play around logarithm questions. In subsequent videos, I'll be posting more questions on logarithm, like 10 more questions, and we are going to also look into equational logarithm, where we have to solve for a particular value, maybe x, maybe p, or thereabout. So see you in the next video. Bye.